TPA3255, surprisingly good audio amplifier. I have got more and more questions about TPA3255 and amplifier performance based on this chipset. It is the latest Texas Instruments chip-based Class D design with max power outcome of about 300 watts. For practical applications, I would say that we are able to get out of this board about 2 times by 200 watts clean, perfect power on 4-ohm load. It is amazing achievement comparing to Class AB designs, where typical high-end amplifiers in acceptable price range capable to deliver only 80 to 120 watts. Another benefit is design size and weight. You can build extremely small footprint amplifiers and combining with good switching mode power supplies, they will deliver the outstanding sound quality. Those budget designs have high ratings in Audio Science Review Amplifier Review Hierarchy. In my personal opinion, this chipset is killing AB Class D amplifier market in power range 100 and 200 watts. The only challenge is to find good power supply for your chosen board. Power supply will determine your system performance. Designs of this chipset are very popular in China market. There I did quick search and the internet browser responded with number of options. Here is Texas Instruments reference design. We'll come back to this design later on. Another interesting board what is simplified reference design, as you can see. There are several versions of such kind of board designs. Here is clear evolution of the board. It is smaller, but still seems decently built. You can see that the first savings are coming here on the large capacitors. Another one, interesting integrated version based on this chipset. Here is a 4-channel version. We will drill down later on this board. This board seems decently built, but it's not available anymore. Another interesting design is that it has rather high price. But what is important, there is a number of high capacity capacitors, and that improves sound quality. This board has so-called in-loop filter design, and its price is very high. I would say there is no reason to take it. There's better solutions in the market what you can take from iSpower for the same price. As you can see, there are a number of options to choose, and it's not easy to pick. Audio Science reviewed it, and you can see that it measures very well. Even a small designs are well measured, and you can see that it's ranking in a top amplifier area. If you do some slight modifications and use a good components, you easily can be here. Here you can see another Chinese built amplifier. I would say it has a decent quality. It builds kind of by the book and using good components. You can see here is industrial power supply. I would say it has rather shy capacitors and output. But anyway, you can get about 150 clean, perfect watts out of it. And well designed, specially designed board for that particular solution. As well, it has balanced inputs and unbalanced inputs. I'd say it's a decent amplifier. The only thing what we can complain it's about ventilation and airflow. So you can get a lot of watts out of it. But in average muting listening in near field, it's about 20, 30 watts. There are peaks. But I would say this is a good design. This is a good design. It is mentioned as a 2 times 200 watt amplifier. In reality, you will not get those 2 times by 200 watts, but you have a significant headroom and you have high linearity and good quality out of it. This chipset draw attention for big companies as well. Such professional company as iSpower added in the lineup one board what is using TPA3255 chipset. It's somewhere here in the bottom part of the board. I like this board design. It's very easy to implement. It's reliable, and if you look at technical specifications, it is capable to 200 watts. In a stereo mode a little bit less, 2 times 150 watts per channel, but with a really good parameters. And this board performs so well that I built a kit for that. And if you want to build your amplifier, or you have already board, I have 2 options for you. I have TCR 200 DI amplifier kit. This is a box with all harnessing done. You just assemble a board and attach a connectors, and your amplifier is ready. Also, I have some integrated amplifiers. All of them are built with a balanced input. Balanced input you can use in balanced format and in unbalanced format by using adapter cable. I price it is kind of average, but it is aluminum case, very small footprint, excellent quality. And I also made some comparable tests. You can find them in my YouTube channel. It's here. Just search for Gunter Smits, and here you can find, if you search for 200 AS2, there are several combinations for active speaker systems, and also I did a blind test comparing more powerful units with a better damping factors. I would say this board performs very, very well. For those who are looking for best of the best, there is TCR 1200 DI amplifier kit. You can build absolutely amazing 600 watt stereo amplifier. I also made some videos for supporting that design. If you put in a search 1200 AS2, you can see active speaker systems, how to implement a trigger. This is for a Russian speaking audience, sampling instructions. So everything is here and many more. Actually, this channel is dedicated to Class D amplifiers, mostly ice power amplifiers, and you can find a lot of interesting stuff, as well as even a speaker building. I built very nice Trolls Gravesen speakers and then filmed all the process. This is a really exceptionally good speaker, I would say, and I never had such quality in my life before. Okay, let's come back to TPA 3255 boards and drill down in the details. Draw your attention to the optimum power supply voltage for this board. I'm pretty sure that Ice Power did hundreds and hundreds of tests to find the optimum power supply value. If you put it maximum of the 48 volts or 50 volts, it will be very hard to cool it, not even with a big heatsink, because the biggest problem what we will face is a heat transfer from chipset to heatsink. And to really get a maximum out, that you have a proper cooling and maximum power and maximum headroom and maximum quality, it's about 42 volts, no more. Then you can drive 8 ohm load, you can drive 4 ohm load, you can drive even 3 ohm load. Anyway, everything will be fine. And this board also has large and high power, specially designed for an audio power supply. It's the biggest value of this board is quality of power supply. If you simply look how much power you need for that 2 times 200 watt amplifier, you need 450 watts power supply. A very good board. And if someone would ask which board to choose, I would recommend this board, because you will have absolutely perfect design. It's by the book all around. I measured it, I tested it, I listened it. It sounds great, and it's integrated with power supply. As I mentioned, power supply is absolutely critical component. It's not easy to find it, and you should understand what you found and how to use it. There's a big difference between industrial power supplies, what are meant for a constant load, or for audio amplifier power supply. When you have very dynamic load, typically crest factor of music is 8. That means average power to peaks is 8 times. That means if you are listening at 10 watts, what's the typical power you are listening, that drums and kicks, those are 80 watts. If you're listening at 20 watts, it's 160 watts, and this power supply should easily handle. Industrial power supplies are not able to handle it. You should either modify or do some additional improvements, but they are not built for that. They are too big, too bulky. They are meant for a constant 400 watt power delivery. That means they will have also fan and etc. Anyway, if you can afford, the cost for this board is 160 in Sound Import Shop. I recommend to buy this one and implement in your designs. It's the smallest footprint what you can get, and it has a balanced inputs as well. It's a perfect match to professional audio cards or audio interfaces. Very nice design. How to choose best board for you? And I would say that you should compare with the reference design. And here is Texas Instruments homepage with the reference design, and you will find several similarities with Chinese designed boards. You can see it has a high price tag because it is meant for engineers. There are additional a lot of test points and jumpers you can set in different modes and different configurations. Is it high price or low price? If we compare to engineer costs to build a prototype, this is very cheap. Any company who is designing something and want to implement that chipset will buy a test board and test it in all possible ways. Also, what is good with a test board? Test board is built by the book, so this is a maximum performance you can get out of this chipset. All components are selected properly by manufacturer, and manufacturer wants that this chip is used, so they do their best to build top performing reference design. It is supported by number of documents, schematics, bill of material, PCB layout. There's more literature, different white papers, certifications, application notes for a multi-device configuration, technical articles, LC filter design. It is important for equality, proper grounding. That is explained from engineering point of view how close they are to Class AB amplifiers or how they are outperforming that. It's worth to read it. There's a lot of rumors and a lot of battles in internet about different amplifier classes and which is the best, and I often get complaints or some arguments that Class A is the top and Class D never be close of that. And also there is special article discussing how important is inductor. And also when you are looking for your top board, you should pay attention who is manufacturing this inductor, and is it in a low distortion list or it's not. Okay, let's quickly look to schematics. This reference design provides schematics, and most of boards what we will find in AliExpress or in other resources who are selling those China boards, those are kind of clones of this reference design. And you can see they're using pretty cost-effective specialized audio op-amp. It's very popular. There's as well number of discussions about should you use a better op-amp or this op-amp is good enough for audio. You can see that reference designers are saying that those are good enough. Definitely, it's also not influence or not make any quality issues. If it would be important, there definitely will be better op-amp if it reflects to outcome or sound quality or measurements. So you can use and utilize those NE5532 op-amps, and you'll find that many of designs have it. Also, those Chinese designs has sockets that you can replace op-amps, but honestly saying, there is no reason for that. So there are several jumpers. You can set it in a single-ended, in balanced, in 4-channel options, in bridged options, in bridged configurations. You can do a lot of stuff around it. I would like to draw your attention how is made this 12-volt circuits, and you can see a lot of filter capacitors, and there's also inductivity. What is coming from that power supply, that inductivity filters out high frequency noise. This high frequency noise could come from power supply, could come from internal circuits, but for a good designs you need this inductivity. Also you can inspect your boards and check is it built by the book. And those capacitors are located nearby the chips, by input circuits. Here you have a power amplifier, and I would like to draw your attention. Here is a large storage capacitors close to chipset, and there are two of them. Roughly saying there are 10,000 microfarad capacitors. In that case, when you have 10,000 microfarad capacitors, you can use industrial boards. So if you want to use industrial 48 volts board, you should add in output additional capacitors. Either they are located in a board. If they are not, then you should add one more element in your schema. What else? We should look to output filter, and output filter is based on 10 microhenries and 1 microfarad 250 volts capacitor, and it will not be very small. If the capacitors are very small in your board, it's not a good sign. It's not a good sign. There are certain amps what those capacitors should handle, or certain power, and this high voltage and capacity together, they are reflecting to potential power what those capacitors can do. Those are at power outputs. What else we should inspect? You can see that power supply maximum power what you can apply is 53 volts, but I mentioned it will be hard to cool it. It's better to go down to 48 or even better for 42 volts. And from this mains voltage, there is a special voltage down converter, high efficiency, what should create service voltages, and it's down converting from roughly say from 50 volts to 15 volts, and then those 15 volts are stabilized by another 12 volt linear stabilizer. It is also high efficiency solution, and then you get stable 12 volts what are critical that they could be stable, and this is needed for a main chip operation. And from those 12 volts there's also another one, linear stabilizer, what is setting modes here in for the main circuit, and here is a legend of that you can configure with those switches or configuring how you apply those voltages to inputs. When you have a ground and ground, then you get 2 times BTL. It's the best possible quality. You can get a super high quality stereo out of that. Then you have configuration 1 in BTL and 2 in single-ended. For single-ended you need capacitors at output. Actually it could be good for 3-way speaker solution. And what you can get, parallel BTL. Actually, you can put all outputs in parallel and drive 2 ohm load and get a 600 watts out, but it's not the best solution. Actually, it's rarely happened that it's used in this way, and you can get a 4 times single-ended. But engineers using that jumper options can configure that test board, the reference board in different configurations and test all of them. Also, there is different frequency settings what you can configure by using different values of resistors. Of course, there are some what is optimum for some of the configurations. I can't say which one is the best, but I'm pretty sure that designers knew that. Most of boards what I have seen, they are set about above 500 kilohertz. Those clock frequencies. What else is worth to mention? Since it's a single power supply designs, here is a midpoint, a very simple midpoint setting for operational amplifiers. You can see resistive divider. They divide this 12 volt voltages in 6 plus 6 dividers. There's 6 volts. V mid is 6 volts, and they reinforce it a little bit by 10 microfarad capacitor. That means those op-amps are using very low current that you can do it with a 10 kilo ohm resistive divider. This is also important what value to use. Either you should use provide higher current, or you can use just a resistive divider. And you can see those mids and are attached to the positive op-amp input. One more thing to check when you buy a board. As I mentioned, here's a 50 volts, and that down converter should be 50 volts rated. It's better to rate it for a higher voltage. And you can see LM 5010 ASD blah 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 has 6 to 75 volt wide input. So it definitely fits in our design. But if you look at some Chinese designs, and you will find out that there are converters what's rated about 45 volts, and that's not good. I'm working on the marginal voltages, and better or later they will fault. For those who are hearing operation amplifiers in audio circuits, those are extremely gifted persons, and here I want to just show you that how good is this NE5532 op-amp, cheap op-amp, very low noise, high bandwidth, high common mode rejection, high DC voltage gain. This op-amp is maximum capable to deliver 26 volts at 600 ohms if you have plus minus 15 volt power supply. It's not our case, but generally speaking it's very good. It's high sleeve rate, 9 volts per microsecond. It's good, especially when we are talking about small signal values. Anyway, you can find better parameters, but for audio is not a difficult signal for operational amplifier. Anyway, you can use more expensive, better specs op-amps, and if you hear it, then do that. I'm not able to hear it. One more thing to pay attention: the reference design is built on a high quality proven component providers. There are far more than those, but all of them are exceptionally good component providers. Now, what is good when you use a proven manufactured components? Your price definitely is going up, but there are a lot of quality tests and checkings, and there's high probability that your board will work for a long time. And you can trust the parameters what is given. You shouldn't measure it. Can you buy from the third parties? Of course you can. And for home usage, it doesn't make sense to buy most expensive manufactured components. But probably the key chips is better to buy by the proven manufacturers. Also, you can study types of components, what is used. For example, when you use ceramic capacitors, there's a reason for that. Even they are small, you can use it for a filter, for example. Because there are different temperature characteristics and stability and internal inductivities. So you should drill down in the specs on each capacitor and choose the right one. One more important thing, LC filter design and quality of it is critically important. And when you choose your board, you should choose with a properly made output filter. There's a white paper about it. Read it through. Try to understand what they are saying, even if you don't want to calculate anything. Just you can think about recommendations how to build it. One more in design tool section, you can find LC filter calculator. And let's a little bit drill down because it's important when you check your amplifier output filter quality. You should understand what does it mean, and there is a compromises. Each for Class D amplifiers, when filter is not in a loop, we have filter dependency on the load. And let's take filter type BTL, common mode, 50 kilohertz. And what we got? We got that for 4 ohms and 50 kilohertz bandwidth. What is typical for those solutions? We need a 9 microhenry inductivity and 1.1 microfarad filter capacitor. So the closest is a 10 microhenries. And let's make a graph for 1 microfarad. So what we got for different loads, and then we will take that. Here is a larger scale, and in that case you can see at 20 kilohertz. According to theory, we should have minus 0.5 decibel drop for a 4 ohm load, and plus 0.8 decibels for 8 ohm load. So here is those are compromises. There are compromises, and that means for a higher loads, we have some deviation on 20 kilohertz. How critical is 0.5 decibels on 20 kilohertz and 4 ohms? No, first I can't answer because I'm hearing only up to 14 kilohertz. I'm aging. But our sensitivity at a region of 20 kilohertz is maybe 3 decibels we can distinguish. Hardly. So it's neglectable. Even a couple of decibels are not important. But in the forums you can find out that people are discussing those 20 kilohertz drops and complaining, and they're saying that Class AB is better. Now, yeah, saying the class AD is better, it's a lot related. What is your system performance? It's far more important how your low frequencies are presented. Are they suspended or not? And when we're talking about this amplifier has a warm sound. What does it mean? Typically, it means that it can't reproduce a low frequencies. It's not sufficient, does not have sufficient power for that. But in most cases, simply power supply is not able to deliver the necessary power, and then they kind of soften the bass and low frequencies. So it's warm. I like this warm sound. It's not warm. Amplifier is bad. If we summarize output filter for a bridged solution, we need 10 microhenries and 1 microfarad. Those are closest what we can get in the market, and you should check are they correct or not. Often it's recommended even measure it. It is critical values, and those should be correct. So this is the end of part 1, where we look at the theory. In the next part, part 2, we will take one real board and inspect it in the details and take some measurements.